Hello everyone and welcome back. So what do we have here? Well, we have the arm of the robot. It's extending at a constant rate. Okay. Constant rate of r dot equals 1.5 feet per second. I like that. I like that. And we know that z is going to be equal to 4t squared feet. And theta is going to be 0.5 t radians. So we have an equation for both of those. Also very good. What we want to find is the velocity and acceleration of the grip A when t is equal to 3 seconds. So, with that in mind, we know quite a bit here. Seems like we got a lot. We also know that r is equal to 3 feet is our initial condition. So with that, I think you have enough. So, this is a group problem. Grab your group members. Call your cat, your dog, your stuffed animals. Get them over here. Sit them next to you. I have my traveling gnome. We're ready to do the problem. Once you've got it all together, pause, try out the problem, and see how it goes. Now I won't send you off without anything. Here's your plan. Use cylindrical coordinates. Okay, it's not the best plan, but still, come on, I had to give you something. And I think it'll be enough. Also, this whole constant thing might be very helpful at some point. So, go forth, try it, then come back and see how you did. So 3, 2, 1, and let's check it out. So when t equals 3 seconds, we know that r is equal to 3 feet. That's what we said at the beginning of the problem statement. And the arm is extending at a constant rate. If it's a constant rate, that means that our double dot is going to be 0. But r dot does not change with time. So we know what theta is, and we can take a time derivative to get theta dot. Take another time derivative to get theta double dot, which is just 0. We know what z is, and we can take our time derivatives there as well. Z doesn't have anything weird, it's just regular old time derivatives. Even if we were just doing z by itself. It's very nice in that way. It's just the exact same as when we had our Cartesian coordinate system. So then if we want to plug it into our velocity equation, we'll just do r dot, r theta dot, and z dot as our components. We know all of those, so we plug in our values. And if we want to get the magnitude, well, we do our Pythagorean theorem, but now it's for a 3-dimensional line. So it has 3 components. Each of those squared, added together, and we get the square root. How about the acceleration? Well, acceleration is the exact same problem. However, it is simplified somewhat in that we know that theta dot is equal to 0. We also know that r double dot is 0. So it does get rid of a little bit of this, not everything. We plug everything else into our equation. And what do we get here? Well, we get 6.75. We get 4.5 from here. And we get 8. That's just plugging in our numbers from earlier. All these calculations right here. Now, as a note, I did forget a negative sign right here. That should have been negative. But it doesn't matter when I'm getting my absolute value for my acceleration. Just don't forget your negative signs. Be very careful about that. I usually give you multiple tens on the homework, so it's not usually an issue there. And I will give you lots of partial credit if you forget that on a assessment. But still, practice. Make sure you're doing it right the first time. So just like with velocity, we want to get our acceleration, magnitude of it, and how do we do that? We take all of our components, we square them, add them together, and then take the square root, and it comes out to be 11.4 feet per second squared. So that's it. What is your method? Your method is always to use what it gave you. If it gave you an equation, like it did here, to take a bunch of time derivatives. If it gives you words like constant, then you know that the next thing is going to be 0. So if it's constant rate, well, r double dot is 0. If it's a constant radius, well, then r dot and r double dot are 0. There's all these different things that could be happening here. Theta will never be constant. If it is, you're no longer in a cylindrical coordinate system. You just have an XY coordinate system then. So it will never be 0. But it might be 0 at some point, it just will not be constantly 0. So take what you're given, look for these fancy words like constant, and then take your time derivatives and plug everything in. Just be very careful with it, and you should get it right. So thank you for listening. If you need more problems about this, let me know. Send me an email, and I will record more examples. Have a wonderful day. Bye-bye.